Status, a modern solution for sustainable net management of sewer, water and gas infrastructures, reveals the hidden potentials of your network. Urban settlement areas have become more and more dense throughout the process of urbanization taking place during the past decades. This was followed by the installation of the lifelines for the cities, the infrastructures required for water, gas and energy supply, and sewage disposal. Due to the enormous extent of these veins, a reasoned net management is mandatory to preserve serviceability. These networks, installed ages ago and more or less continuously extended according to the prevailing needs, deteriorate due to corrosion, abrasion, and many other loads and stresses they need to resist. This decay and the resulting possible major consequences, such as flooding or breaking into the open, need to be stopped. Unfortunately, the networks are out of sight in the underground, and without inspections, all actions are based on presumptions and are rather speculative. For this reason, continuous monitoring of the network condition, for sewers for example, by TV inspections is mandatory. In many countries, therefore, these inspections are required by law. Each TV inspection delivers various data sets related to the inspected sewer section. To draw the complete picture of the network, the data available from all inspected sewers is needed. All inspection data and their relations need to be correct, consistent, and plausible. Therefore, a sophisticated data analysis guarantees the quality required. This three-level analysis supports quality control in sorting and evaluating the data stock before storing in the database. Realistic assessment of existing damages is the key for an optimal network maintenance solution. However, common damage evaluation models do include only damage type and extent. In advance, Status ensures a detailed and holistic damage assessment by including additional parameters such as material, diameter and wall thickness, soil type and pipe cover, groundwater level, and various stress and load impacts. All these attributes are linked by fuzzy logic, in which the various parameters, always pairwise, create a three-dimensional result field. These resulting 3D matrices are linked to the corresponding results of other fuzzy logic processes. Thus, for the first time, it leads to evaluation results which are extremely close to reality and reflect the true impact of the damage under the different viewpoints. Without Status, this accuracy is only achievable by a costly individual assessment. The damage assessment is the basement, and followed by the section assessment, which is divided into condition assessment and assessment of the substance. The condition indicates the priority of action, whereas the substance, standing for the where reserve, reveals the type of action, such as repair, rehabilitation, or replacement. Section with local heavy damage. Urgent action required, but no replacement needed. Complete section with minor damages. Schedule for replacement. Based on section assessment and age deterioration, behavior of the network can be determined. As sections deteriorate differently, the network is clustered according to age-relevant attributes. For example, the selection of all sections made of concrete, having a cover smaller than 4 meters and a diameter smaller or equal to 350 millimeters, gives a group of sections being more homogeneous in their aging behavior and speed represented by the specific survival functions. This is done for all remaining clusters. Having determined the cluster-specific deterioration, Status is taking the next step and predicts the aging of single sections. The mathematical background for this is the model of Markov chains, which calculates the transition probabilities for condition and substance. Based on the now well-determined aging processes and other parameters such as economy or hydraulics, The impact of the various maintenance actions on the network can be predicted. This finally results in optimized maintenance strategies, which are balanced between costs and network demands. The different steps of status provide you with detailed knowledge on your network condition and performance, now and in the future, considering all relevant ancillary conditions. That gives you flexibility for planning your resources and security against unexpected failures and the resulting heavy consequences.